Assalamu alaikum. In this lecture we are going to find the generalized circuit constants. So what do we want? We want to define the transmission line by using 4-terminal network. That is actually a black box which is represented by some constant, and there are two terminals that are on one side of the block and there are two terminals on the other side of the block. At the left side or on the left terminals we have sending end voltage and sending end current, and on the right side or right terminals we have receiving end voltage and receiving end current. And these constants, they are based on the type of transmission line we are using, whether we are using short transmission line or medium transmission line or long transmission line. So we want to represent each transmission line by its constant, and for transmission line we have a generic model that is represented by 4-terminal network. But before defining these constants for the transmission line, there are some characteristics of the terminal network that are to be studied. For example, the first one is passive. The equipment that has to be defined by the 4-terminal network should be passive. So for transmission line, we know that it is passive because we do not have any source in the transmission line. Transmission line itself is connected to some transformer or generator, but the transmission line itself do not consist of a source, so it is a passive component of the power system. Then the second property is linearity. It should be linear, means impedance of the transmission line should be independent of current. Impedance is independent of current. As the frequency in the power system is same, frequency is either 50 Hz or 60 Hz, but it is constant for a certain power system, right? So if frequency is same, the XL and XC value is constant because frequency is not changing. So XL value is omega L, this is 1 over omega C. So if omega is not changing, then these value will be constant. So impedance is actually independent of current value, so it is linear. The third property is bilateral. Irrespective of the current direction, the impedance value will remain same. Whether current is flowing in one direction or the other direction, the impedance is independent of the direction of the current. So the impedance value is constant. So the transmission line is bilateral as well. So we can represent each of the transmission line, short, medium and long transmission line, by 4 constant A, B, C and D, with 2 terminals on the left side and 2 terminals on the right side. On the left side we have sending end voltage and sending end current. On the right side we have receiving end voltage and receiving end current. And we can write that Vs is equal to AVR plus BIR. Is is equal to CVR plus DIR. So these are the constant, the generic constants for each of the transmission line. Once we know that these constant, we can find Vs, Is, or we can find Vr, Ir if we know Vs or Is. So there are some general characteristics of the constants. they are generally complex numbers. And from these four constants we have A and D which are dimensionless. B has a unit ohm, whereas for C it is Siemens. A will be equal to D, and for all the constants AD minus BC is equal to 1. And all these characteristics are applied to all the types of the transmission line, whether it is short, long or medium transmission line. Now let's take an example of a short transmission line. So for a short transmission line we have resistance and inductive reactance. We do not have any capacitance in the shunt branch because it is neglected in the short transmission line. So if we will write the equations for this circuit, we know that the sending end current will be equal to the receiving end current. Similarly, the sending end voltage will be equal to the receiving end voltage plus the voltage drop across the impedance. So from the last slide we know that Vs is equal to A VR plus B IR, and Is is equal to CVR plus D IR. So this is the equation that will be compared with this equation. So we know that D is equal to 1 from the comparison of these two equations, and C is equal to 0. Similarly for these two equations, A is equal to 1 and B is equal to Z. So A is equal to 1, B is equal to Z, C is equal to 0 and D is equal to 1. And from the characteristics of these constants we know that A should be equal to D and it should be dimensionless. So A is equal to D, 1, 1, and these are numerical values, so these are constants, so it is dimensionless. B should be ohms, right? So impedance, the unit of impedance is ohms, and C should be admittance. So there is no C in this short transmission line because we neglect the admittance of the line. So the capacitance is neglected, admittance is neglected, so C is equal to 0. So this is the 4-port representation of the short transmission line. Thank you.